Good morning to one and all. See this, in this today's live lecture, we shall study the classification of first order partial differential equation. See this, in this lecture number 5, we shall discuss the classification of first order partial differential equation. See this, in this classification we shall write here. Now then we shall move towards curves and surfaces, genesis, PDE. Okay. Now classification of a first order partial differential equation, but before that we have studied first order, that is a definition of partial differential equation, definition of partial derivative, then partial differential equation, order, degree and degree of a partial differential equation. Then we have studied, also we have studied, that is a notification of a partial differential equation. Now today we shall start the classifications of the partial differential equation. 1 minute. Okay. Now in that classification of a partial differential equation, we shall study the different types of classification of a partial differential equations into linear, that means linear, semilinear, quasi-linear and non-linear equations with examples here. So classification of a partial differential equation, we shall take number 1, linear equations. Second, semilinear. Semilinear equations. Third is quasi-linear. Equations, and fourth is basically non-linear equations. Non-linear equations. See this. Now we have to write, there are different types of a partial differential equation. Basically we shall discuss only the first order partial differential equation. In that first order partial differential equation, we can classify the partial differential equations into the linear equations, semi-linear equations, quasi-linear equations and a non-linear equation. These are the 4 types of first order partial differential equation. Okay, only the first order partial differential equation. Now we shall discuss one by one here. Linear equations first. See this, a first order partial differential equation of first order partial differential equation generally, which is commonly denoted by f of x, comma y, comma z, comma p, comma q, which is equals to 0. See this, the function of first order partial differential having the function of x, y, z, Z is the dependent variable, X and Y are the independent variable. P means dou Z by dou X, Q means dou Z by dou N. Means an equation which containing these terms, then that equation is called as a first order linear partial differential equation. Is known as a linear, if it is a linear, in P, Q and Z. P, Q and Z. See this. When we can say that these are the linear, a first order partial differential equation f of x, y, z, p, 0 which is equals to 0 is known as a linear if it is a linear in P, Q, Z. It has a degree 1. Okay, and we can write this as, if the given equation of the form, stop there, if the given equation of the form P of x, y into P, समजा हा P म्हणजेच इथं वाटलं तर मी दुसरा फंक्शन घेतो, कॅपिटल P, हा इथं लक्षात ठेवा, P of x, y into small p. P is a function of, capital P is a function of x and y into small p. Small p means dou z by dou x plus Q of x, y. P of x, y into P plus Q of x, y into Q. Into Q means Q is dou z by dou y, which is equals to R of x, y into z plus S of x, y. See this, here P, Q, R, S, capital P, capital Q, capital R, capital S are the functions of x and y. Small p and small q are the notations which are used for dou z by dou x, dou z by dou y. Okay, note that is. For example, we can write this linear equation. For example, first x square y into P plus xy square into Q, which is equals to x into y into z plus x square y cube. Second example, also we can write P plus Q, which is equals to z plus xy. P plus Q, which is equals to z plus xy. So this differential equation is called as a linear differential equations. Okay, याला आपण काय म्हणतो, linear differential equations. Okay, 1 minute. Now we shall discuss the second semi-linear differential equation. We can say semi-linear equations. A first order partial differential equation a first order partial differential equation of f of x comma y comma z comma p comma q which is equals to 0 is said to be is known as a semilinear equation if it is said to be semilinear equation if it is linear in P and Q. If it is linear in P and Q and the coefficients of P and Q are functions of x and y only. Functions of x and y only, that is full stop there. The form of this type of equation is, we can write in the general form, capital P of x comma y into small p plus q of x comma y into small q which is equals to r of x comma y comma z. फरक लक्षात घ्या. Here in this case s of x comma y is not there. That means the first order partial differential equation P of f of x comma y comma z comma p comma q which is equals to 0 is known as a linear if it is linear in P comma q and z. If the given equation of the form P of x comma y into P plus q of x comma y into q which is equals to r of x comma y into z plus s of x comma y. See this, for example, x square into y p plus x into y square is q into q which is equals to x y z plus x square into y cube. This is also linear, this is also linear. P plus q is equals to z plus xy. But semilinear means a first order partial differential equation f of x comma y comma z comma p comma q which is equals to 0 is known as a semilinear equation if it is linear in x and y and the coefficients of p and q are the functions of x and y. The form of this semilinear equation is in this way. You shall write the one example. You can write example of this is first xy into p plus x square y into q which is equals to, suppose we can write x square plus x square into y square into z square, or we can write second example y into p plus x into q which is equals to x square into z square divided by y square. That means in this case s of x comma y is absent. Okay, so this type of a differential equation is called as a semilinear differential equation. This can be this, see this term will not appear in the semilinear differential equation. See this, linear equation implies a semilinear equation. See this, if s of x comma y is equals to 0, then we can say that the given linear equation must be in a semilinear differential equation. Okay, now next we shall discuss the third example, third type, and that is a quasi-linear equations. Quasi-linear differential equations, or we can write equations. Quasi-linear equation. Okay. Now what is the definition of a quasi-linear equation? A first order partial differential equation of the form same f of x comma y comma z comma p comma q, which is equals to 0, is known as a quasi-linear partial differential equation if it is the linear in p and q. If it is the linear in p and q, so we can write the differential equation of the form. Generally it is denoted by, see this, one minute, see this next, a first order partial differential equation f of x comma y comma z comma p comma q, which is equals to 0, is known as quasi-linear equation if it is a linear in p and q. So there is no condition about x and y. There is no condition about x and y. See this, p and q, but coefficient of p and q are the functions of x and y. It may be arrived or it may not be arrived. So we can write in this way also, that is, which is in the form of the quasi-linear differential equation, which is in the form of, here, capital P of x comma y comma z into small p, capital Q of x comma y comma z into small q, which is equals to r of x comma y comma z. But it is essential that linear in p, but there is no in condition about the coefficient of p. For example, here we can write, for example, suppose p plus q, which is equals to xy. Second, we can write as x square minus xz into p, y square minus y zx, एक मिनिट, x square minus x कॉमन निघू शकतो म्हणून yz, y square minus zx into q, which is equals to z square minus xy, z square minus xy. See this, are first order Cauchy partial differential. These are the examples of first order Cauchy partial differential equation. See this, combine the degree of this x square minus x square, yz means x square is same. अशा पद्धतीनं फर्स्ट ऑर्डर हा x आणि p आणि q च्या कोएफिशिएंट साठी पर्टिक्युलर कंडिशन नसते. So these are the actually third type, that is a Quasi-linear partial differential equation. Now we shall discuss the last, that is a 4. We can say non-linear equation. The definition of the non-linear equations here. A first order partial differential equation differential equation, a first order partial differential equation which is denoted by f of x comma y comma z comma p comma q which is equals to 0 is known as nonlinear equation if it is not come under the above three types. Okay. See this, a first order partial differential equation f of x comma y comma z comma p comma q which is equals to 0 is known as non-linear equation if it is not come under the above three types. या तिन्ही टाइप मध्ये जर येत नसेल तर ते सर्वच्या सर्व कसे असतात, नॉन लिनियर असतात. नॉन लिनियर. सी दिस फॉर एक्झाम्पल इट इज डिनोटेड बाय, आता ह्याला जनरली काही म्हणजे डिनोट नाही करता येणार पण कोणत्याही पद्धतीने असू शकतं. इट मे बी फंक्शन ऑफ आर एस, इथं आर येऊ शकतं, पी क्यूच्या जागी एस येऊ शकतं. सेकंड ठीक आहे, मी पाहतो आता. वी कॅन राईट धिस एक्झाम्पल विच इज कॉमनली जनरल, वी कॅन डिनोट द जनरली, याला जनरली दाखवता येत नाही. कोणत्याही कंडिशनमध्ये नॉन लिनियर असू शकतं पण त्याचं आपण एक्झाम्पल्स लिहू, आपण लिहिलेले पण आहेत. एक्झाम्पल फर्स्ट, नंबर 1, पी स्क्वेअर प्लस क्यू स्क्वेअर इज इक्वल्स टू 1. or we can write it is also dou z by dou x bracket square, degree is not 1, plus already we have defined non-linear equations, dou z by dou x dou y bracket square equals to 1. This is the non-linear. Second, p into q which is equals to z. There is a product of dou z by dou x into dou z by dou y which is equals to z. This is also non-linear type. Then third, which is also denoted by x square into p square plus y square into q square which is equals to z square. All these are the non-linear partial differential equation, are the non-linear partial differential equations. See this, there are number of problems you can write in the non-linear partial differential equation. Okay, now how to form, now we shall discuss how to form the partial differential equation by eliminating arbitrary constants. So next write down heading, formation of the partial differential equation. As like a formation of a ordinary differential equation, there is also working rule for the formation of a partial differential equation. As like, now we shall interest, okay, formation of a partial differential equation. How to form the partial differential equation? By eliminating arbitrary constant, because the formation of a partial differential equation is different. But if it is the partial differential equation, there should not be arbitrary constant in the partial differential equation. Partial differential equation मध्ये arbitrary constant चालत नाही. Means for the formation of a partial differential equation, there is a parallel one method eliminating arbitrary constant. If we if we taking the partial differentiation of the terms, then that will not the partial differential equation. If we want to say a partial differential equation, it doesn't have, it does not include arbitrary constants. So you can write this as every partial differential equation. Now here in this we shall, in here in this section we shall discuss the methods for the formation of a partial differential equation. Partial differential equation by eliminating, it is very important, by eliminating arbitrary constant. हा बेस तुम्हाला माहित असणं गरजेचंच आहे. त्यामध्ये मेथड फर्स्ट, actually there are two basic methods. First method, derivation of a partial differential equation by eliminating arbitrary constant. Derivation of a partial differential equation by eliminating arbitrary constant, by elimination of arbitrary constant. See this, actually again there are three methods, again there are three working rules for eliminating arbitrary constants. Again there are three working rules. If arbitrary constants, number of arbitrary constants are less than number of independent variable, then we have to use different process. If number of arbitrary constants are equal to the number of independent variable, then we have to use another process. And if the number of arbitrary constants are greater than the number of independent variables, then we have to use different formation methods. So different working rules. So first of all we shall discuss the general process. Consider an equation, consider an partial differential equation, which is, only we have to discuss about the linear. So capital F of suppose x comma y comma a z comma a comma b, which is equals to 0. Suppose this is equation number 1. Now student, you tell me how many independent variables are there in this equation? सांगा बरे या इक्वेशन मध्ये how many independent variables are there? Actually in this equation there are how many independent variables? There are two independents, that is x and y, and arbitrary constants are a and b. Z is a dependent variable, or suppose, sorry, in this case f is a capital F is a function of independent variable x comma y comma z comma a comma b, where a and b are the arbitrary constants here, and z is regarding as a functions of two independent variable. Here a and b are arbitrary constants, full stop. Let z be a function of two independent variables. Two independent variables x and y. So now we cannot differentiate we can differentiate with respect to, or differentiate equation 1 with respect to x and y partially, then we get differentiating equation 1 with respect to x and y partially. How we can write this? Then we can write as dou f by dou x. If we differentiate this partially with respect to x, dou f by dou x, z is a function of, now we are differentiating only partially with respect to x. So dou f by dou x plus dou f by dou z, because z is a function of again x, so we can write dou f by dou z into dou z by dou x, because z is again a function of x. Then constant term will be a